Hello, my name is William Frederick, and this is my presentation for Poli 170A for my final project. In my research, the question I wanted to answer was, how does the personal characteristics of a country's leader affect their country's military spending? To answer this question, I looked at 3 different characteristics that could potentially have an effect on military spending, those being leader age, leader gender, and if the leader had a prior military career. So why do I believe this question is so important? In politics, a politician's personal story is often viewed as incredibly significant. Gender played a crucial role in the 2016 election, age will be a key factor in 2024, and historically, countless politicians have touted their status as military veterans in election campaigns. In this research, I'm attempting to substantiate the practical impact of these personal characteristics. I want to see if they prove to have any quantitative effect on a policy realm as important as military spending. Going into my research, I had expected that older leaders, male leaders, and leaders with past military careers would on average spend more money on the military than leaders who were younger, female, and did not have past military careers. When conducting background research on how age might affect military spending, I found a lot of conflicting information. One study I found showed that older leaders are more likely to engage in war. Furthermore, studies on how age affects decision-making shows that older individuals tend to be more cautious, while younger individuals tend to be more brash. One could argue that this caution might manifest in older leaders allocating more funds to defense spending as a precautionary measure. Conversely, it could be argued that the brashness of younger leaders might drive them to invest more in the military. Finally, in the wake of Putin's invasion of Ukraine, there has been considerable discussion about how Putin's age may have influenced his decision-making. There has also been speculation that the conflict may have been an attempt by Putin to secure a legacy. If true, this would be an example of how age-related motivations can prompt increased military expenditure. In regards to gender, there has been research conducted which shows that female leaders are typically more collaborative than their male counterparts. Behavioral studies have also shown that women are less physically aggressive than men. While I had expected that these observed gender-based differences might manifest in gender-based disparities in military spending, the only study I was able to find that examined the relationship between gender and military spending had a null result. I struggled to locate any solid research on how prior military service affected a leader's support for military spending while in office. I was, however, able to find a study that examined how prior military experience influenced the future militarized behavior of leaders. It found that leaders with prior military experience but no combat experience were most likely to initiate military disputes. In spite of the lack of substantial prior research on the issue, I still expected that a positive correlation would be found between prior military experience and military spending. For one, I expected that leaders who had prior military experience would be overall more trusting and supportive of the military than those without it. I also expected that leaders with prior military experience would be better able to rise to power in countries with more substantial militaries and higher numbers of veterans, which would therefore result in them on average spending more on the military. To test my hypothesis, I used the RAIN dataset shown on the slide for my 3 independent variables. I had to recode the variables in that dataset for leader birth date and leader starting year into a variable for leader age. Binary variables for both gender and prior military experience, on the other hand, already came with the dataset. For my dependent variable, I used the percent of GDP spent on the military from the CIPRI dataset. For my control variable, I decided to control for democracy. I used the VDEM Electoral Democracy Index as a measure of this. I also had to control for the issue of year in my data. I achieved this by coding new variables for the yearly averages of my independent variables and then subtracting these averages from my independent variable observations. I did this for each of my 3 independent variables, giving me the variables of age difference, gender difference, and military career difference. For something like age, this would mean that an observation of -7 in age difference would indicate that a country's leader was 7 years younger than the average age of leaders internationally for that year. For the variables of gender difference and military career difference, the interpretation is a bit more complicated. A gender difference value close to -1 would mean that a country had a female leader in a year with few female leaders. A gender difference value would never actually reach -1 because that would mean a country had a female leader in a year with no female leaders. But the lowest gender difference value in my dataset was -0.9927536, which was for India in 1968, where Indira Gandhi was the only female leader in a year with 157 male leaders. My variable of military career difference is similar, with values closer to -1 indicating a leader did not have a prior military career in a year when most others did, and a number closer to +1 indicating that a leader did have a military career in a year when most others did not. As can be seen on my slides, my unit of analysis was country year. I had initially planned to use leader year as my unit of analysis, but found country year to be more manageable when merging my datasets. When converting from leader year to country year, I had to grapple with years that had multiple leaders. For leaders who shared a country year, I took the average of their ages and set the gender to female if any leader in that year was female, and prior military career to true if any leader in that year had a prior military career. In the end, I had data from 159 countries spanning 71 years from 1950 to 2021. When I ran my analysis, I did 4 sets of regressions in R. In my first set, I ran 3 bivariate regressions in which I just looked at the effect of my raw IVs on military spending. In my next set, I also ran 3 bivariate regressions and looked at the effects of my IVs using the IV difference from yearly average air variable I described earlier to control for year. Then I reran my first set, this time as 3 multivariate regressions controlling for EDI score. Finally, I reran my second set, also as 3 multivariate regressions controlling for EDI score. I believe this final set was the most important as it controls for both year and democracy. In this slide, you can see all the regressions I ran on my data. In terms of statistical significance, age was only statistically significant after controlling for the year through age difference. Gender only showed statistical significance when controlling for year and EDI. Gender also had a much higher p-value than my other IVs, implying that the statistical significance for gender is not as strong. Prior military career was statistically significant in all 4 sets of regressions. Although many of my results are statistically significant, the strength of my effects are all fairly weak. The slopes of my regressions show that age, gender, and prior military career each account for less than 0.01 percentage points of GDP spent on the military. My R-squared values were also quite low. In the models that did not control for EDI, my R-squareds were less than 0.01, meaning that they were able to explain less than 1% of the difference in my DV. Once I controlled for EDI score, my R-squared values increased to roughly 0.05. These new R-squareds meant that these models could explain roughly 5% of the variance in my DV, which is still relatively low. I will now focus specifically on the last set of regressions that control for year and EDI score. The slope of my regression for age is 0.0001485, which indicates that when controlling for EDI score, for every year a leader is older than the average leader in that year, military spending increases by an average of 0.0001485 percentage points of GDP. For the regression between prior military career and spending, the slope is roughly negative 0.005. This can be interpreted as when controlling for EDI score, a leader with a prior military career will spend on average 0.005 percentage points of GDP less than a leader without a prior military career in the same year. For the regression between gender and military spending, the slope is negative 0.0043. This can be interpreted as when controlling for EDI score, a male leader will spend on average 0.0043 percentage points of GDP less than a female leader in the same year. As mentioned before, this was the only regression I ran where gender was found to have any statistically significant effect, so I would personally keep a healthy level of skepticism when looking at this particular result. One interesting thing I found is that while a prior military career is initially shown to correlate positively with an increase in military spending, once I controlled for EDI score, the correlation between a prior military career and military spending became negative. This next slide shows graphs I created for each of my IVs. The top graphs are the full graphs, while the bottom graphs are zoomed in to provide a clearer picture. For the x-axis, the blue graph shows age difference, the red graph shows gender difference, and the green graph shows prior military career difference. The y-axis on each graph is the percentage of GDP spent on the military. The color variation for my data points is being used to display EDI score. Darker purple points represent countries which were more democratic, and lighter purple points represent countries which were less democratic. I noticed a few interesting things not directly related to my research while looking at these graphs. One is how we can see that the proportion of lighter points is much higher on the right side of the military career graph as compared to the left. This indicates that leaders with prior military careers are more likely to lead less democratic countries. I also think that the graph for gender does a good job at visualizing the numeric disparity between male and female leaders, with there being significantly more male leaders in my dataset compared to female leaders. To conclude, what are some improvements I could make to my research? For one, I think my research would be significantly improved with more comprehensive data on military spending. The graph on this slide shows where values are missing in my military spending dataset. As you can see, there are a lot of holes. I think that analyzing other confounding variables could also allow me to better isolate the effects of my IVs. I believe it would also be worth considering trying to use more complicated methods of analysis to analyze this question. The professor and I discussed panel data and the possibility of using PLM regressions. Finally, I think that further research could be conducted on the topic of how personal characteristics of a country's leader affect other policy areas besides military spending. Thank you for watching my presentation.